In this video, we'll look at how to do cross products in MATLAB. You may have seen cross products before in vector calculus or physics class or some other class. If not, don't worry about it. I'll tell you what they are. Cross product is an operation you can do between two three-dimensional vectors. The result of the cross product is guaranteed to form right angles with the original two vectors, which is a nice thing to be able to do. The size or magnitude of the resulting vector is based on how big your other two vectors are. So it does depend on both size and direction of a vector. So I'm using the word 3D here not to be a matrix with 3 dimensions. I'm using it in old traditional, like we're representing things that are happening in 3-dimensional space. So what that tells me is that my two vectors have to have 3 items in them. 3 elements. So let's do this. Let's make 2 vectors here. Let's call them A and B. A is 1, 2, 3, and B will be something different, -1, 2, 1. They have 3 elements in them because they represent a coordinate in 3-dimensional space. They're one-dimensional arrays in MATLAB because they only have 1 row. Okay? Now we can take the cross product of the two of them together by using the MATLAB command cross, which is really nice. Cross A, B. Okay, let's take a look and see what we get. -4, -4, 4. Oh, why is that weird? Oh, look, both of them have the same y coordinate. That's not what I was expecting. Let's change it and make it a little bit more interesting. Run section. Now we have a 0, which is fun. What we are getting is a coordinate of another vector. So we're getting another vector. The product of 2 vectors is a vector. The cross product of 2 vectors is a vector, unlike dot product, which gives you a scalar. So we get, I'm going to go back to 2 here, run section. We get another 3D vector. One-dimensional array in MATLAB with 3 elements. But it represents a coordinate in 3 space, in 3-dimensional space. So this is equivalent to -4 in the I direction, or the X direction, -4J, which is in the Y direction, plus 4K, which is a unit vector in the Z direction. Right? This is not the same I and J from imaginary units. Sorry, we just ran out of letters, so we're using I, J, and K. Anyway, cross products are widely used in fields like fluid dynamics, statics, electrical engineering problems, a lot of things. So let me just check real quick. Do you think cross B comma A will give you the same thing? With this one, we add a negative and a negative and a positive. Run section. It's the same numbers, but with positive, positive, and negative. This is cross product is what we call anti-commutative. You get the negative or the opposite of what you got when the direction was reversed. Okay, so now we can use cross products. There's some nice examples in your book using cross products to solve engineering problems. All right, that's all for now. I'll see you in the next video.